See, question number 8. A body of mass m moving with the velocity ui, I cap, unit vector along x-axis, collide elastically with a stationary body of mass 3m. This is 3m, its velocity is 0. If velocity of m after collision, this becomes Vj. J cap is unit vector along y-axis, and 3m has some velocity as shown in figure. The value of v is, v की क्या value होगी? You have to find. ठीक है? Simple question but technical. See, suppose velocity of second 3 I have taken as v2, v1 is v, and I have assumed that it makes an angle theta with the x-axis. So by law of conservation of momentum along x-axis, what happen? Along x-axis, law of conservation of momentum, what happen? Mu here 3m0 is equal to no component along x-axis, what happen? M0 यहाँ 3m क्या होगा बेटा? अगर हम हैं इसका कंपोनेंट लें, दिस इज v2 का कंपोनेंट along horizontal, तो that it becomes v2 cos theta. Here component will be v2 sin theta. Horizontal component is v2 cos theta. तो यहाँ पर क्या होगा बेटा? m this m cancel, तो u is equal to this are 0 0, तो 3v2 cos theta. First equation. Along y-axis what happen? If we'll say along y-axis, mean along unit vector j cap. Here no component. Before collision no component, so after collision v positive, तो then v2 sin theta, यानी mv this is positive, तो this is negative 3m v2 sin theta. So if you will take m with mm cancel, तो v is equal to 3v2 sin theta. Second equation. If squaring and adding, what happen? So u square plus v square, u square plus v square is equal to cos square plus sin square 1. So what happen? 9v2 square. 9v2 square, 9v2 square, cos square theta plus sin square theta becomes 1. So one result we have found it. U square plus v square is equal to 9v2 square. Elastic collision is there. So law of conservation of energy. Kinetic energy. Elastic collision, both momentum is conserved, kinetic energy is also conserved. Here what happen? Half m u square, velocity 0, that is 0, is equal to half m v square plus half 3m, its velocity is v2, so v2 square. Half cancel, mm cancel, the u square is equal to v square. Here half m cancel to 3v2 square. v2 square you can put here. Firstly multiplied by 3 full equation, to what happen? 3u square, 3v square plus 9v2 square. 9v2 square is u square plus v square. Put here 3u square, 3v square, 9v2. That is u square plus v square. You can simplify it. 3 square minus u square, that is u square, is equal to 4v square. What is the relation between u and v? We can find the relation. Squaring root to u is equal to 2u square is equal to 4v square divided by 2. You can find the relation u is equal to root 2v, or v is equal to u upon root 2. Here we can see what we can see, v is equal to u upon root 2. So first option, here we can see that first option, A option, is the correct one. V is equal to u upon root 2. There are two things we have done: elastic collision and total linear momentum is conserved along x-axis. This is elastic collision in 2-dimension based problem, and kinetic energy is also conserved. By the help of that, we have found the velocity. One question is there: stopping potential of emitted photoelectron is V when monochromatic light wavelength lambda is 4. What they are saying? If wavelength of light becomes 3 lambda, stopping potential of photoelectron becomes V by 4. Threshold frequency of metal is k lambda, then k is equal to. Very important question. This year they have asked 1st September JEE 2020 in first shift. Simple problem is there. See what are the relation between incident light and work function and stopping potential. We know h nu mean hc upon lambda is equal to work function plus if stopping potential to ev naught is there. So here c they have given v naught is v and incident light lambda. So this will be the first equation. Second equation, what happened? 3 lambda incident wavelength. What happened? Potential becomes v upon 4. So that is ev upon 4. Solve this. We have to find threshold wavelength. So firstly we will find work function, then we easily we can find the threshold. So subtracting 1 from 2, what happened? hc upon lambda minus hc upon 3 lambda. W naught work function come ev upon 4. 1 minus 1 by 3, this is 2 by 3. hc upon lambda is equal to 3 by 4 ev. This is the relation between this. So if you are putting ev here, what will be the relation between w naught and hc? So if you are taking here, so 3 by 4, so this is 4 by 3 into 2 by 3, hc upon lambda is equal to ev. So one relation we have got it. ev is equal to 8 by 9 hc upon lambda. So this ev we have put it in first equation. So from equation 1, hc upon lambda is equal to work function plus ev is equal to 8 upon 9. 8 upon 9 hc upon lambda. So see here hc upon lambda minus 8 upon 9 hc upon lambda is equal to work function. So 1 minus 8 by 9, this is 1 by 9. So hc upon 9 lambda, hc upon 9 lambda is equal to w naught. So see here, threshold wavelength. If threshold wavelength is lambda naught, so w is equal to work function is equal to what? hc upon lambda naught is equal to here hc upon 9 lambda. So you can see here what will be the threshold frequency, threshold wavelength. So lambda naught is equal to 9 lambda. So here we can see K is equal to 9 lambda. Option C is the correct one. Question number 10th. This year what they have asked, 1 September first shift, fundamental frequency of two identical string X and Y are 450 and 300 Hertz respectively, then find the ratio of tension. Easy problem, very easiest. They have given frequency. So what is the relation between fundamental frequency? 1 upon 2L under root T upon mu, या T upon M, mass per unit length. This is tension. So N directly proportional to under root T. So what happen? We can say T directly proportional to N square. So TB upon TX upon TY. is equal to fundamental frequency Nx upon Ny square. So what is the Nx? They have given 450 upon 300 square. So what will be the ratio between the tension of X and Y? So here we can see 15 2s are 0 0 cancel. So 3 by 2 square, that is 9 by 4. Here B option will be the correct option. We know fundamental frequency is directly proportional to under root tension T. So T directly proportional to N square. Simply we can find the ratio in tension. Is there? They have given a block of mass M start slipping top of inclined plane B and comes to rest when reaches at lowest point A. BC is equal to 2AC. Friction coefficient of part AC. CB is smooth, but part AC has friction coefficient mu is equal to K tan theta. Find the value of K. Okay, see here AC, BC is equal to twice of AC. So let AC is equal to L. So BC is equal to 2L twice. Then AB is equal to L plus 2L, that is 3L. So we know at inclined plane. At inclined plane, any object is there at an angle theta. So how many forces? So weight mg. mg will act downward. So it has two components. One is what? Mg cos theta, and either component is mg sin theta. So effective acceleration you can see here, mg sin theta weight will act along the BA. Okay. So see, work done by gravitational force, initial it is rest, finally it is rest. So work done by gravitational force is equal to work done by friction force. Both will balance each other. That's why what happened, because initially it is rest, B पर वो रेस्ट पे है, A पर also रेस्ट पे है, तो work done by gravitational force from B to A is equal to work done by friction force. तो work done by gravitational force, तो we can see here their mg sin theta component will be along BA. This will be the force acted by gravitation upon the block M, mass M. So work done by this force, gravitational force, mg sin theta. And what are the friction force? So we can see here that is the normal reaction. Normal reaction will be N is equal to mg cos theta. So what will be the friction force? The friction force is equal to mu N. Mu into N. N is what? Mg cos theta. So this is the force acting by friction. And here mg sin theta is the gravitational force acted upon the ball. So here initially kinetic energy is 0, final kinetic energy is 0. Kinetic energy B zero kinetic energy at A also zero. A also zero mean what happened? Kinetic energy at B also zero. So this mean work done by gravitational force is equal to work done by friction force. So what we will say? Work done by gravitational force. Gravitational force is equal to work done by friction force. Friction force. Here gravitational force will act from B to A, and that force is mg sin theta. So here mg sin theta force acting along the and total length AB is 3L is equal to work done by friction force. So friction force will act how much? Mu mg cos theta, and this will act for length AC. AC is L. If you simplify here, the mg cancel, L cancel. What happened? Mu is equal to 3 sin theta upon cos theta is equal to mu, or you can say mu is equal to 3 tan theta. So they have given mu is equal to k tan theta. So k tan theta is equal to 3 tan theta, or we can say k is equal to 3. So which option is correct? Here we can say C option will be the correct one. To see next question what they have given, 12th question, 1 September first paper. Find minimum value of f applied perpendicular to line OP. This perpendicular line OP where O is center, half ball of mass and radius is R, required to lift the ball. इस बॉल को लिफ्ट करने के लिए, ठीक है, कितना मिनिमम फोर्स F रिक्वायर्ड होगा? दे हैव गिवन दिस 4 ऑप्शंस. तो सी दिस इज द सरफेस, ठीक है, एंड वन बॉल इज हियर. इफ यू आर टू लिफ्ट द बॉल, ठीक है, बाय F, तो यू कैन सी हियर टॉर्क प्रोड्यूस्ड बाय F is equal to what? Weight will act downward, mg, ठीक है. तो this will give anti-clockwise torque by mg. तो clockwise torque by force F both are equal. Then when clockwise torque will increase, it will lift. Okay. So what will be the torque produced by force F? This is R. So torque produced by force F clockwise, ये क्या होना चाहिए बच्चों? That is greater क्या होना चाहिए? एंटी क्लॉकवाइज टॉर्क किसके कारण? ड्यू टू mg, यानी हम कह सकते हैं एंटी क्लॉकवाइज टॉर्क. जैसे ये क्या होगा? ग्रेटर होगा, इट विल लिफ्ट. तो क्लॉकवाइज टॉर्क का मतलब क्या हुआ? फोर्स इनटू परपेंडिकुलर डिस्टेंस. नॉर्मल रिएक्शन विल पास थ्रू हियर, ठीक है. तो वी आर टेकिंग द रोटेशन अबाउट पॉइंट P. रोटेशन मीन एक्सिस ऑफ रोटेशन व्हाट वी आर टेकिंग. तो नॉर्मल रिएक्शन व्हाट हैपन? दे विल पास फ्रॉम द एक्सिस ऑफ रोटेशन. तो दैट डजंट मीन, ठीक है, नो टॉर्क विल प्रोड्यूस्ड बाय द नॉर्मल रिएक्शन. तो एक्सिस ऑफ रोटेशन पासिंग थ्रू हमने कहां से लिया है बेटा? रोटेशन is passing through point P. Torque, clockwise torque, mean F into R. That should be greater than anti-clockwise torque is what? क्या होगा बेटा? mg and perpendicular distance. तो यहाँ पर हमें perpendicular distance, तो perpendicular distance suppose this is P, this is N I have taken. तो mg इंटू क्या होगा? Pn as Pn, ठीक है. तो this you have to calculate. What will be Pn? तो we can see here when we are going to calculate. suppose this angle is theta, so that will become r cos theta. Pn mean क्या हो जाएगा बच्चों? That is r cos theta. अच्छा, this is a, तो this is also a, तो remaining that is r, so that becomes r minus a. This angle is theta. So what about this side? NP, this is OPN. So NP is equal to what? Pythagoras theorem, r square minus r minus a square. That is r square a square plus 2ra. r square cancel, तो np square. तो np square is 2ra minus a square. So that is np is under root 2ra minus a square. So here we can see here f greater than mg. What is pn? Pn I have told you that becomes r cos theta. So r cos theta, that is pn upon r. So r cancel. F should be greater than mg cos theta. So what will be the value of cos theta? We can see here cos theta is equal to base upon, that is np upon hypotenuse r, op, and np we have find it here. तो cos theta is equal to, cos theta की वैल्यू कितनी आएगी? अंडर रूट 2ra minus a square divided by r. So if you are putting here, so that is 2ra minus a square divided by r. So here we can see f should be greater than this. The minimum value of f to lift the ball, so that is what? mg under root 2ra minus a square upon r. So 2ra upon a minus a square upon r. So we can see here B option is the correct one. For lifting ball, rotational torque clockwise should be greater than torque produced by weight in anti-clockwise. So here we can apply, we can find the value of required value of force, minimum force.